This conversation that we don't know about that. I hope you really enjoyed the discussion and the sessions this morning. We've got a really great panel session for you now. So get thinking about those sessions that leave us hanging with the questions at the end. We've got four, I think, very different perspectives around obviously the central topic of decarbonisation. So we have Olaf and Donna from Einride, who are going to come on in moments. They're going to be followed by John from Volvo, by Greg from Allseas, and then Justin is going to talk about the realities of making these things happen from the perspective of the John Lewis Partnership. So we'll do presentations, we'll do some questions at the end. Please, I want to see plenty of hands up. Yeah, but to start off, I'd like to introduce Sarah and Donna from Einride. Thank you. Thank you. Hopefully we can start from the beginning as well. Yeah, so can the microphone? Is it on? No?
Is it on?
No.
No, it's not on. Is it on now? No. 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 Good. Thank you, everyone. My name is Ola Bones. I know some of you from before. I used to be at Chalmers University. 3 years ago, I left and joined this company. And this is my colleague Donna. She will take over the last half of these minutes. We're from a company called Einride. That's how we pronounce it. You can pronounce it however you like. If you're German, you will say it like probably. Anyway, we do not sell trucks. That's the first thing I'm always saying. We do not sell trucks. A lot of people think that we are an OEM that we sell autonomous trucks. Well, we don't. We are basically a transportation company. And we are looking at transforming the transportation system into something that's electric, very digital, and highly automated. And these are 3 different work streams, if you will. And they coincide, and there will be some critical moments down the line where we actually need to pass some gates in all of these 3 in order to take the next step. But the automation is basically the marathon going on beside the electrification and digitalization, which is the ones moving past at the moment. Why we're doing this is that we see that 90% or more than 90% of the Fortune 500 companies have aggressive climate targets, and they don't really see solutions in the existing industry. This is, if you listen to Fernando's segment, this morning, this is Fernando take 2, basically, because it's the same message. We need to look through the windshield and not the rear view. If we want to solve the challenge, because the challenges are that 7 or 8% of the carbon footprint is caused by these companies needing to move stuff around on the surface. And looking at the internal combustion engine vehicles, if you want to plan for a nice vehicle, you need 3 things. You need to know how much, where does it need to go, and when does it need to be there. And if you know all these 3 things, and you know the capacity of your vehicle, you can generate your 2% profit margin. That's how the industry works. The industry is basically a big spreadsheet. It's not more complex than that. You just copy paste the same solution if you want. If you try to do this with an electric vehicle, if it works on Monday, you will have problems on Tuesday because it's raining, or it's windy, or it's another driver, or your competitor is standing next to you charging, and all of a sudden you introduce new variables contain feedback loops, it becomes really complex really fast. And if you scale it up from one vehicle to a fleet, you increase the complexity even more because you realize that you need your own energy infrastructure. So you go from the fully, and I mean fully commoditized world of road freight today, where everything is commodity. Everything is more or less interchangeable, especially when you talk about long haul, to a system where virtually nothing is commodity. You need to all of a sudden invest in your own energy infrastructure. You need to look at, you need 5-year contracts in order to be profitable. And this is in a world where 3 months is the normal. So there are so many new things to keep track of. And also you need to meet, of course, the profitability targets. Increase your revenues or your profit per ton kilometer as much as possible. What would it take to solve these problems using the best available technology, not using any legacy unless it's absolutely clear it's the best way to do it? That the challenge that we are looking at. How to employ the best available tech in order to solve the problems, not take the least possible step in order to keep as much as possible untouched of the historic system. We say build the right system from scratch. This is about how we approach electrification, and this is also where we are scaling, if not the fastest, one of the fastest scaling companies in the Western Hemisphere at the moment. And we are doing it by reimagining the system. So you need the full systems perspective. You cannot cherry pick and replace the truck, because everything around the truck needs to be looked at as well. The energy, the planning, the digital infrastructure required, because it will become a combinatorial explosion of complexity to manage these systems, because you need so much attention to detail. And I will leave to my colleague Donna to talk about what we're actually doing then and where we are in the world.
Thank you. So I have the privilege of taking the idea and actually making it operational. So this is no longer conceptual. This is very much live in action. And you can see, oh, that's not great colours. But the really bright green is where we are live, and the lighter green is where we will be live, essentially. And we have some really big players that have taken the leap with us to roll out on this decarbonisation journey. So you can see the likes of Maersk. Over in the US, we have PepsiCo, we have Heineken. So these are not small companies. These are large companies that have really complicated and unique to them logistics and supply chains that we have to make sure continue to run smoothly whilst delivering their net zero goals. And so this is great from our perspective with regards to building that footprint and scaling. It's also giving us a wealth of data and understanding of how to do this. So we've been up and running as a company since 2016. We've had live operations from 2020, and that has given us a wealth of data to really understand, get rid of some of the bugs, work with the OEMs on the different vehicles coming through. So it puts us in a very unique position. All right. And so what do? We really wrap our arms around everything. So it starts at the top with our kind of transformation program, where we will take all the data from the customer and understand, how do we electrify? How do we make this work in the real world? Then you have kind of the central sections. So my colleague said, we're not a truck manufacturer. We're not. We will work with whatever company provides the best vehicle for the solution that we need to execute, which puts us in a really unique position. As well as that, charging. This is huge. It's not just about the vehicles, it's about having the right infrastructure to support those vehicles. Unfortunately, we can't just pick up an electric truck and run it like a diesel. For all the different complexities that Pierre had outlined, we need to factor in that charging infrastructure, and that is part of our kind of offering as well. And then on top of that, we need people to be able to do that. So we need to work with carriers who can provide people, the maintenance and the service, and we essentially own all of that. But the one thing that really pulls us apart is this bottom part, and is our operating system Saga. So it's having the analytics that underpin and do everything from reporting your CO2 emissions through to telling drivers, actually, you need to stop now and charge for 20 minutes rather than 2 hours, because that's going to prolong the battery life and get you to where you need to be. So it's having all of that understanding to fundamentally deliver the customer's kind of goals from a CO2 perspective. And then ensuring you have the right software. So I touched on it, but software is critical and it is a game changer. And this is where you can see some of the stats that we have seen coming through from the data of how we can bring down costs from truly understanding how to operate this in the minutiae of the kind of data sets, whilst also increasing the battery life. So we have extended warranties on our batteries because of how we operate them, making sure that we don't overexert them and we use them within the right means. And these are just some of the stats. I'd love to talk to you about all of them, but this is what is important to our customers and to us to make sure we're driving costs in the right direction, but also then managing kind of the product life cycles as well. And finally, we touched upon this, but the charging grid and green corridors is critical to the success of this. So this is something that we are working on in the different regions to which we operate. And this gives you a snapshot of where we kind of see the initial laydown of the charging network being executed in the UK. This covers all the main corridors and really encapsulates the density of routes that we see in these areas. So it is planning for the long game, but this is where we essentially would start when kind of bringing this to life for our customers. And I could go on. So we're working, and I think the bit that we need to also understand is how much charge you need, how much you'll be taking out of the grid, when and where, and making sure that we are planning for the right kind of usage. So overall, Enride, our proposition is we have the experience to be able to do this. We have the underpinning of a really strong digital kind of narrative. We know what we want to do and where we want to go with the grids to make sure the infrastructure is there to provide the right framework for our customers. And then finally, autonomous is our North Star. So whilst we're doing all of this, our end game is very much how we then build our autonomous offering. And that is everything. Thank you very much.
Thank you very much, Donna and Paola. Yeah, thank you very much. Great presentation. Very thought-provoking. I'd like to introduce our second speaker now, John Tomer from Volvo, continuing a little bit of a Nordic theme here. John, you can have that. We'll switch your presentation on there. Look forward to it.
Good afternoon, everyone. My name is John Tomer from Volvo, and this week I think that we live in Volvo trucks and man and boy. In that time, I had the during driving progress and inside the during Swedish weather and Swedish summers. Maybe £5 forever, but there we go. It's all a bit expensive there. But yeah, we maybe there's a fair amount of legacy driving natural. Not particularly that. In 1927 we started out. We have a local truck company. We sell all around the world, very much in Sweden. We have nothing to do with the banks, but apart from the brand, that's ideally we're very much independent. So we are transitioning really hard from diesel because we put our engines in the trucks. We also put them in plants. So construction equipment and dancing. We also put them in marine. We have Volvo Penta, for instance, Southampton Boat Show. 60% of the boats at Southampton Boat Show have Volvo power. So it's a really big company in terms of industrial engines. And so we have rooms on the truck and rooms on the map, and we have collaborations with Dongfeng and Osher in the Asian market. So it's a company that's driving very best. Well, we're still waiting for the next year. We're still waiting for the second, and one year, It's there. Combustion is still in terms of thermal efficiency and kinetic energy recovery. And we're also seeing that delivering real bottom line savings. It's not just about CO2 reduction, it's still in his previous work. We know it's also being green or keeping the green on the bottom line. There's been a huge uptake on the renewables. We couldn't do flame engines, fatty acid methyl ether engines, but we don't like them because they have reduced service intervals. So our diesel range is all there. Driving fuels, sustainable, renewable diesel HVO are good otherwise reduced. Also reduce the number of carbon atoms that we can bust because we also have a methane on them, and 100 vehicles are operating here in the UK with methane. So we get a 20% reduction in the tailpipe. But is less. And I think it's very much a problem of, excuse the pun, using what I was doing too, they're not notified. So electric, and then our future drive is fuel cell. So the current problem is very much for duty trucks in 2019. That is a refuge vehicle, that's not battery balance and rotating body. Duty tractors, which we will see online, coming on stream this year, will be around about 150 to 200 by the end of March on the road, both on mass and tippers. And then heavy duty range, including up to 8 wheelers. So again, one of the things that we're seeing is not only just a transition in the truck, but a transition in the type of truck, the architecture of the truck. New platforms. We have got to market with an existing design because of the level of complexity in terms of what the trucks want and need to do. We have joint production of diesel, electric, and LNG all down the same line. So we have production in Ghent, production in Sweden, and production in France, all going down the same line. Energy density is the key for us, and it's been touched on earlier. Getting the fuel on board is very difficult. So we got 140 kilowatts. Those of you who are able to come up to there to see this, will take you through what we're doing there, how we're changing the network, and how we're making it a full reality, and you'll be able to see the vehicles there. So diesel is an amazing technology. Tesla is a household name now, but diesel was there before. He only explained to the fuel, but also to the engine as well. There's also got a self-driving line and perfume. So you can see that we've got 130 kilograms in terms of storing that energy for 3 tons. So some dimensions of where infrastructure are a key element in making this work. We were, I think it's called a survey trial, to allow operators to get out and try these vehicles in service. And again, it's interesting this morning listening to ISO 14093, science-based targets, Scope 3 emissions. What is that driver to change? What is your why? Is the key element that we're looking at to make a transition. And we've got some out there. We had the Fox took the first 2 tippers there, and it's never ever had so much interest from people who want to know how you make holes in the ground. Everything that's the stuff that comes out of a hole in the ground, but being up in the agriculture, you couldn't get the same, or the trucks were significantly more expensive, but he couldn't get the same PR exposure that he got from those 2 trucks, which he openly admitted. But again, he made that a big one of the ground, which has a big CO2 issue. So again, let's try to offset that emission there. We've got mixers in there that have skips. So we've got a short range of city trucks. So I'm very to make that difference. We're going to be making a bit of those underneath, but the structure on top is built by somewhere else. And again, we've got a beauty now of the duty truck, then we've got DHL, then we've got Ford, then we've got service now. It's and no issue. So you're able to take the vehicle into a quarry or underground. And I like the particular thing in the UK. We're very fixed on having a tipper or reaching up the body. I like the thing of the 2 approach where you have a sliding body and you can make it work whatever way you want to, great problem to the local industries. So that's what the reaction is to the first electric vehicles going into service. Good technology there.
The biggest aspect of the truck has been how seamless it has fitted into the operation. We thought we would see a lot of barriers and challenges, but with the support of Irish Commercials, the dealer, we've foreseen a lot of these issues and it has worked pretty well. So we don't have any issues. So that has been the biggest surprise really, that it's worked so seamlessly.
For me personally, the benefits of driving the electric is it's just so quiet. I like a nice quiet cab. It's peaceful during the day. I can listen to my music, my podcast. For the weights that we can carry up to like about 8 tonne. So in the diesel, it would be hard to drive. It would take quite a wee while to speed up. For electric, you just go. It's just, it doesn't struggle to pick up the pace, stuff like that. Yeah, that's why I enjoy it.
When it comes to range anxiety, you don't really have any, because as long as you look at your set route in the morning, you know you're going to be all right for the rest of the day. So you can have everything on in the cab if you want. You can have lights on, aircon, radio, everything, charging your phone. I don't sit there and drive along and watch the mileage go down or anything. I don't pay attention to it, to be honest.
In terms of driving style, I suppose I've probably made 3 big changes. So the first change would be, generally speaking, trucks are limited to 90 kilometres, and I found personally that dropping from 90 to about 82, 83 kilometres makes a huge amount of difference. It conserves the range phenomenally. In my opinion, I would say I conserve energy by about 20%. I think it's a game changer for me. Secondly would be how fast you build up your speed, particularly with an electric, with the amount of available torque and power. It's very easy to put your foot down, but obviously in terms of energy conservation, it's not very prudent. The third thing then would be the regeneration technology of the retarder on the truck. I was amazed, A, how efficient the retarder is in the new truck, and B, the amount of power it harnesses. With effective use rather than braking, you can really extend your range.
I was excited to drive the electric truck. I'd never driven one before, so I was looking forward to trying out. I wouldn't be in a hurry back to driving diesel trucks. It's a much quieter driving experience and more pleasant experience in the cab as well.
There's no real limit to what we can do with the trucks. We've looked at it, so first of all we have trucks doing domestic Irish work, doing up to 300 kilometres a day. They work perfectly for that without having to charge. We also then have them doing trunking at night, going up to Belfast and back down. Our experience is very good. We can manage, we can fit them in perfectly into our model, even though we've no charging network available in Ireland at the moment.
Volvo Connect is good in the fact that we can download all the data from the vehicle, so we can compare it on a weekly or monthly basis as to how it performs against the diesel vehicles. We can take the charging and the electricity that is used, and it's roughly using about 40% of what fuel would cost. So again, that's an interesting indicator that although the capital cost of the truck is more expensive, but longevity on the running costs of the vehicle should start to balance out maybe around about 5 years. The biggest surprise that we've had introducing the electric truck is the response from our customers. The customers absolutely love it. We would never have thought that it would have made such an impact on the business as what it has.
So the electric is part of the drive reaction. Frequency dynamics have changed. And the other one there with electric tech is how these trucks develop the character of the road. It's generally you can see probably around about 2030 in production. And I think so that's obviously where the fuel source comes from. And the same way, we have to look at the data and we have to look at ways of transitioning. One of those ways is subsidies. And again, here you can see we've also got our H2 vehicle running to test steam oil. So we get more incentives, we've got more needs and I'm probably the biggest factors about it. We have to look at EV cars because of incentive to change. And now we're back to the incentive to change in the matter and a significant like that, if you look at the costs. So, from the same way, we can see the price there with depending on the event or not. But the electric is, 2026, actually comes to 5.2 cents per kilometre. There are massive increases in terms of moving goods through euros. So, we can't really change. We're on the competition. We've got a strategy and then we've got a competitive incentive to change and hopefully new structure grows. Thank you very much for your time.
Thank you very much, John. Really great insight. I'm looking to hear real feedback from the people that are operating trucks as well. So next I'd like to introduce Graham to the stage. Graham's going to continue the theme, I think, of the art of the possible. Over to you.
I think it's been better overall we get down to competent by detail about what the analytical data much more working on. So which one is it?
It's
So we're really today. We're talking about the trucks which are most quick, but that's not get some days look at that what I thought about fish trade operating and that is fish trade so it's a big element of issues and cars that companies shouldn't be forgotten about. So we'll talk a bit about how we're and I think that we should throughout while we're here. Look at we really go around technology. We also purchased more in the UK 2019, which was so now we've got those versus the rules when man on average occasion. Currently, the companies all blending technology that run around today, be it on business or be it on back trade operation. So what we're trying to do is get us to use clean engine of the primary motor unit, which can be diesel and CNG. That's really our aim was. So from diesel big engines. They use somewhere around 20 to 30% of their emissions. So in our industrial diesel, compared to the way they are with diesel, Euro 6 truck, very 40 and 50%, almost quite efficient. One amount of time and money that's been invested into these engines. We know that diesel for our new time the noise, you can cut the noise because it comes at a cost. And like any diesel, the more you use it, the more it costs to maintain.
But there's a part of the report that was done by Brian Robinson and the team down at Zemo with regards to testing some TRU, which has not been done independently, and there's some great work being done by Zemo to try and get some standard testing being done. Part of the report said when you couple the tractor and a trailer together, a fridge trailer together, it emitted something like 200 times more diesel particulate matter per kilometre driven and 4 times more NOx. So these really are dirty, and I think it's important just to note that all diesel fridge units on the roads today, certainly in the UK and Europe, there is no filtration or particulate capture. It is combustion to atmosphere. So they all sit around a Euro 2 and Euro 3. So they are really dirty pieces of equipment. So we've got 2 product ranges that sit in this space. One is a hydraulic drive fridge, which I'll touch on very briefly, and the next one is the EcoGen. So we've got 3 standard fridges in the UK, or in operation across Europe and the UK, and we make them all 2 super electric vehicles as well, so they're fully electrified if required. So, but getting on to the EcoGen, it's transition technology. It's only going to be around for probably 20 to 30 years, as long as there are diesel trucks on the road. And if we look at the statistics, with being over 30,000 fridge trailers just in the UK, there was 100 new electric fridges put onto the road last year. So you work out the maths, how long that's going to take to actually get rid of all the diesel fridge units on the market in the UK, at least 20 odd years. So there's going to be, we know that there is a drive and more customers are moving towards decarbonisation. This is an effective way of taking that lump out of your carbon emissions by fitting something to the tractor. So it's a parasitic device. So we'll start with that. Yeah, it's a good parasite. What we do is we take a small amount of power from the host engine, and be it gas or diesel, and we put that through a permanent magnet alternator, and we generate 400 volts at 50 hertz. So with regards to the styles, depending on what tractor you're looking at, we can fit one behind the cab, particularly with LNG and CNG, there's not a lot of space on the side, or if you've got space on the side, it fits onto the side. Again, all it does is generate 400 volts at 50 hertz. Every fridge unit, every diesel fridge unit on a trailer has its own electric motor, which is used generally for plugging into shore power. So all we're doing is mimicking that shore power. Again, this easily swaps onto vehicles, so we're looking at 10 to 12 year life. I think, as a society, we shouldn't be looking to throw things away within 5 or 6 years. We need to make them last longer. So this is literally a swappable piece of equipment. It's modular, so you can change the design very easily. So if you buy the one that's the back of the cab this time around, it can be changed very easily to the side mounted one at a later date. In terms of measuring, what's really important now is that our customers are saying to us, we need to measure the CTO, so we put the telematics into the system. Because there is when you look at a drop and swap operation in most tractor and trailer operations in the UK, it's feasible in one working day, a 24-hour cycle with a tractor unit, it could be 3 to 4 different trailers. So by measuring the system, we can actually quickly populate how much carbon is saved. So that's a really important one that can be reported back. I was in Sweden recently, and the invoicing that was done for customers out there actually showed the carbon output for that delivery. So I think it's very important that customers should be able to see how much carbon they're saving on each journey with the truck, on the carbon saved on the use of the fridge. Coupled into the fridge, it's just a 5-pin standard plug. Many of you may have seen this, most probably wouldn't. Is that every fridge unit, as I said, has a 5-pin plug. So we literally just plug directly into that to supply electric power. So what are the benefits? The benefits are somewhere between 75 and 80% saving on 85% saving on diesel. Direct correlation there to carbon, which is really the important one. And when you start looking at the diesel particulate matter saving and NOx, it really then does come into its own with some huge savings in terms of comparison. Reduced noise, which is good. We've heard about electric trucks. We've had that mentioned with customers by their drivers that are using EcoGen. You don't have a 2-litre diesel engine banging away 1.5 metres from your ear. So that's very helpful. Low maintenance costs. Again, that's been reported that we're now seeing customers saying, I don't have to replace my trailers so often because I can extend them some money on electric, which is an important point now with trailers being extremely expensive. Reduce maintenance costs as well, so you don't need to maintain the diesel engine as much. And all the other things there, and this just, all it does is generate electricity. In terms of lithium battery packs, we're launching later this year, or next year now, we're almost at the end of this year, a modular battery pack from 20 kilowatts to 100 kilowatts. This can be charged and fitted to your trailer, therefore you could always have power available generated by your tractor in your transit. So these are cost-effective solutions that are retrofittable, because whilst we've got lots of work that's being done by fantastic businesses about what's coming down the pipe in terms of new equipment to meet our carbon zero targets, this is the here and now. This is available. It can retrofit to every Volvo, Scania and Renault tractor unit that's on the road currently throughout Europe. But they all have tiny gear in their engines, so this can be fitted retrofitted straight away, and we're doing that very often. So look at the savings. By taking a small amount of power from your tractor unit, you are going to use a little bit more. This is a collection of case studies, and I can't give the names because they were all signed under NDA. But this is a good collection, so you can see that the actual savings there. This isn't something where you're putting investment in it costs more. If you're doing these kind of hours, you are saving money, and a considerable amount of money. But when you look at the carbon saving per tractor unit a year, this is really, I've heard the term low hanging fruit. This is a strawberry, because it's a quarter of the cost to invest in an ecogen and actually go for a full electric trailer. It gives you 60% of the savings. So that's where we are with that one. And let's look at the alternatives. Now I'm going quite quick, so I've only got 10 minutes. So hopefully I'm not skipping too quickly through everything. But when you look at the options for operators currently, I think I've had hundreds of conversations over the last 3 years with this project, and I think where we are now is that there's 4 options. There's do nothing and talk about it, which is probably where 90% of the operators are. Then you can say, okay, I'm going to invest in a new electric fridge, and that's going to cost you about £45,000 extra over and above what you pay today for a diesel one per fridge. So you can see the costs are very large indeed. That's what you can get one, and they're not available currently that easily. So by investing into ecogen, you can see there's a fairly low investment cost to a fairly big gain. I think my 10 minutes are not too far up, because Bill stood there. So a couple of photos that this is not this talking about it. This is real life CNG, LNG, fitted to all labels. The top left one is an LNG. The one below is a CNG vehicle. Again, these are well documented, and they're operating in 5 countries throughout Europe currently. And thank you.
So three reasons you can see, again, more innovation, things that can be done to improve performance immediately. So let's speak of that, and then we're going to go to some questions. Did I mention questions earlier on? I think Martin for those, so hopefully you got all sort of but our series is just the name, just has been at the forefront of the whole decarbonisation debate for as long as I can remember, and it's great to have him here with us today. Question for yours.
Yeah. Well, I'm going to agree with everything that's been said so far, which is unusual for me. I'm also, bear with me as well. I was going to do this as a kind of pre-recorded thing, but I've decided to stand up and blather on anyway. So I'm sure Phil will start throwing things if I want to do my 10 minutes. If I can master this, here we go. A little bit about our fleet. First of all, we have a fleet of about 5,500 vehicles in total. That's everything from maximum weight tractors at 44 tonnes right down to vans and cars. Meet Gary here. Gary runs our workshops. And Phil would have spotted, as others might have, something to Phil, at least is one person that we spotted that one of those parked on a pedestrian crossing. I do have a version of the slide where that's been airbrushed out, but not in this particular one. So we made some commitments, which we sincerely believe that we will achieve. One of them is that we will move completely away from fossil fuels in our fleet by 2030. Another one is that we will be zero carbon. This is okay. Zero carbon by 2035. We're going to do that by electrifying anything that can be electrified. So that's all light trucks, vans, and cars. For the hard to decarbonise long distance heavy trucks, we're using biomethane. We've got about 400 trucks running on biomethane as we speak, and we'll be using HVO biodiesel for those niches where we can't go to either biomethane or electricity. So, for example, we have a farm that's got a combined harvester on it. So I think the electric combined harvester is somewhere off. Hopefully I'll have mastered this by the end of this presentation. What does that mean? So about 500,000 tonnes of carbon saved versus 2020. That's about an 80% reduction in our carbon over the time. Very importantly, it's also revenue saving. So like many businesses, we operate at low margins. We can't afford to do stuff that's going to cost a lot more money. So it's important that everything we do has a business case, and it either has to be on fuel saving or normally a combination of fuel saving, productivity, and other stuff. We'll come back to that in a short while. We also expect to have reduced maintenance costs and some other benefits of this. Making vehicles last a lot longer, for example, is again we'll cover that in a short while. That again is an important key, I think, to unlocking business cases that actually work for this technology. So let's talk about efficiencies, and our eco operation is a really good example. As has been said already, simply substituting a diesel vehicle for an electric one probably isn't going to work. You've got to look at the overall system, and that means minimizing the energy required for that complete transport operation, and that's through using or building vehicles as light as we can, really managing driving style, making sure the route scheduling is as good as it possibly can be. Still doing things by itself. Okay, fine. Having the most efficient system means that we can have smaller batteries in our vans, and that means those are lower weight, so more payload, and it also means that they cost less, and it means that the charging task is then that little bit easier. That means that we can then have a strategy of slower overnight charging, and that, as we've heard already, is that's good for battery life. And again, you're looking at total cost of ownership, but everything you can do to make your batteries last as long as possible is going to be a good thing. So slow overnight charging then also means that your charging infrastructure costs less, because the cost of chargers goes up exponentially as our output increases. And also smart scheduling. That means understanding for each of the routes you're putting it out, how much energy are those vehicles going to need. Most of our vehicles in this operation do 2 routes in a day. So it also means that by understanding the state of charge of vehicles right now and predicting what they'll be when they come back to base, we can then allocate vehicles to the second route based on their state of charge and what that route's going to need. It also means when we're planning the charging that we only charge vehicles up in the morning for the level of energy they're going to need for the following day. We don't just automatically charge everything up for the top value. And doing all of that then removes or partially removes the need for grid upgrades. And I'm very pleased to say in an operation where we have about 170 individual sites operating vans, there's only a handful that will actually need grid upgrade, and we believe by taking these measures. We might also need to achieve that. We might also need some level of load management. So again, it comes back to this thing of having this holistic view of the whole operation. And if that means that we turn the fridges off for a couple of hours because we can afford to do that in order to prioritise charge for vehicles, then that makes perfect sense. Productivity then is absolutely key to making a business case work. And that means matching charging to downtime. We've already talked about the vans, but the vans, in most cases, the luxury is that they're static overnight. For heavy duty trucks, it's a lot more difficult. We have some tractors that are only stationary for 2 hours in a day, kind of Thursdays and Fridays. And that means if those are electric and they need charging, you're probably looking at megawatt chargers, and that is obviously hugely expensive. It also means that in our operations, John's Partnership, we're a supermarket and department store operator. But it's a similar model for parcels when trucks leaving roads because they have to be they have to arrive at multiple sites at more or less the same time. In our case, because that the kind of short life chilled goods, so sandwiches, have probably been delivered that day, and they need to be at the store at 5 or 6 in the morning. So all the trucks leave, arrive at the store, they come back at more or less the same time, and then go out again. And if you're charging back at base, that means you've got to be charging, when you might well have 100 trucks and 200 trailers at a base, you might be needing to charge, say, 40 at the same time. You're not easily going to get 40 megawatt chargers going all at the same time. So these challenges make it difficult. And these slides have got a lot of there again. Let's see if I can get back to it. So that's one thing of trying to avoid charging and destroying the productivity, which when the trucks cost probably 4 times the cost of a diesel truck, isn't going to do a business case any good at all. Minimizing on-road charging. So times when the truck is charging and the driver's in it, theoretically you can do that on a break, but a break's only 45 minutes, and the challenge of tying up the truck with a charger at the right time for the break and the charger's working and there's no queuing, all of that is a bit of an operational nightmare. So other times if you're scheduling a pure charging stop, that's going to be very expensive if the truck and the driver are having to be stationary when they would normally be operating. And by the way, one of the reasons I'm a big exponent of ERS catenary is it solves some of these problems. You charge as you go along, and that helps enormously. And yard management is all about allocating the right vehicle to the right charger. When you come in, so we won't talk about that too much because it's not very exciting. The reason this truck's here, I used to work for UPS for about 20 years, so I know these very well. UPS is very good at making vehicles last a very long time. And that's through the choice of the right materials that don't rust. So this thing's made out of aluminium and composites, and it's designed from day one as if it's going to last 25 years. There's no soft plastics in the cab, for example. So making a vehicle with the right materials, making it robust, means you can make it last a long time. And one of the main challenges of EVs is they cost a lot more than their diesel equivalent, but they've got the benefit of not having all the moving parts and the engines and stuff that wear out. Then making a vehicle like that last, for maybe instead of 7.5 years, making it last 15 years or 20 years, that again can be really key to unlocking the business case to actually make it work. We've talked about the need to make batteries last. So part of that equation is you don't want to be replacing the battery halfway through its life. So it's important that manufacturers such as Volvo, instead of looking at John, choose the right chemistry so that they can guarantee the battery for maybe 10 years. It also means that we need to look at the effect of doing things that like vehicle direct to vehicle to grid. If that kind of thing is a load more cycles through the battery and it doesn't last as long, then the business case for doing that might not be so good. In particular, if you're not getting a huge amount of revenue per kilowatt hour that you're putting back into the grid. And then moving on to energy, very important that's properly sustainable. It's very easy to sort of to delude ourselves that we're on a green tariff, so everything's okay. But if we then plug in a big fleet of electric vehicles in at peak times, there's a good chance we're causing a gas-fired power station somewhere to be started up. So being conscious of or knowing the carbon content of the energy that we're using and trying to make sure that we're charging vehicles at a time when it's lowest, very, very important. And it's the same with biofuels. Not all biofuels are sustainable, so we need to be really certain that the biofuels we are using are properly sustainable. Here we go again. I'm going to check the time on next time. Some of these things through. We also need long-term supplies and price confidence. So that will often mean power purchase agreements, having shareholdings in solar farms or wind farms or radio plants making biomethane, so that we can decouple the cost of the fuel we use from the cost of fossil fuel. We saw when the Ukraine war started off, cost of natural gas goes through the roof, the cost of biomethane follows it, cost of wind source electricity goes through the roof. Look, wind hasn't become more expensive, but the market is based on fossil fuel prices. It's really important to decouple that and achieve a price that we're confident with and comfortable with. And then resilience, most of the things we're talking about today, you require infrastructure to be at the same time as your truck. And normally one will be late. And I've said before many times, put possibly in this room, but if you're lucky, they're equally late. The worst case though is your trucks arrive before your infrastructure is ready. And then you've got all this capital tied up and you can't use it, and you've got people screaming at you because you can't put vehicles out of the road. So timing is absolutely key. Also, very often the specialised needs of these vehicles means you have a single point of failure. So your charging infrastructure in depot, if that fails, you've got a real problem for the morning. No one's going to thank you for it. So making sure you've got redundancy built in, you've got a plan for what to do, you've got really good monitoring so that you know about those problems straight away and you can fix them before they become a real problem in the morning. And energy supplies, having some confidence over energy supplies, and if you've made commitments about moving completely to renewable energy, making sure that you can actually back that up. And I think this is one of the last ones, Phil. So just to throw some more spanners in the planning lead times, very often, be that for infrastructure for building charging sites or gas power stations that can easily stretch into years. That's a huge problem. If you don't own the building, and in many cases you won't do, getting landlord consent, for charging can be very, very difficult. You might have a short lease and you might not want to invest £500,000 in charging when you're moving out of the building, potentially in half a year's time. So there's strategies that you need in order to make sure that you're not just like creating stranded assets. There might be designing charging infrastructure so it can be lifted and shifted somewhere else. And fire safety is a biggie that we don't talk about very much. Parking electric vehicles inside buildings. What if there's a fire? The fire regulations are changing, but it's another risk that needs to be managed. I'm running out of time, so I'm not talking about this one. I'll just talk about the summary then. You can see we've been operating EVs for a very long time. The summary then is have a holistic view of the whole transport system, prioritize efficiency and productivity, absolutely number one, and that message has been reinforced here. Catalyst fund, resilience, and focus on battery life. Thank you very much.
Thank you. So there's a microphones right now. Those questions I was talking about earlier on, I think we probably only got time to talk. And now, thank you very much for our speakers. Who's going to be first?
If you were to have a ranking priority on depot charging, destination charging, or on route charging, and the investment in pocket money points into those things, how would you rank them?
It depends. If you also you definitely work with the definitely don't work really well with the books. So there is one priority that they back. But it makes so much sense. It's whatever solution means the child can utilize the most aspects.
Okay. I will say that the worst one is the average. So the destination charging is an opportunity. It's probably someone else who will need. Someone else who make money from offering charging to whoever is using their terminal. Also a case for over-the-top charging maybe, have a charging pad, like it's users away from the building, and not that's better actually the top is really hard of it.
The demo truck, of course, if you look at the batteries, and it's,
Okay, thank you. Who's next? If your question seems to have tried a little. I've got a couple of sit down. I saw there. Right?
Yeah, that's fine. We're encouraged to think outside the box, aren't we? So I'm gonna do that there with me. Is part of the future of electric trucking, as part of that, do we need to look at the interaction between tracking units and trailers? So was that a point, I think, this morning, saying it takes too long to do a kind of home express. Let's just swap the tracking unit. Yeah, nearly empty battery tracking unit, pull up a drive on here. That takes too long. Are there any moves to speed that up? Are there ways we could better integrate tractors and trailers in our future process?
Yeah, well, at this moment in time, we can still obviously tractors exist because and trailers exist because we have 2 or 3 for every tractor, and the trailer is really part of the logistics system. What's your concern, Brian? Is putting the batteries on the trailer? Or?
Yeah, one of the ways of dealing with having small batteries and not having to stop for a long time to charge them up and allow slow charge is that you simply a bit like battery swapping. This is practically swapping.
Yeah.
Effectively, you drive up to a truck or have your break or do whatever, and you jump out of your truck unit, unhitch the trailer, pull up to a new truck unit in, do the rest of it's the trailer that needs to do go
Which kind of works with the current range of vehicles today. We, for long journey distances, if you're travelling from one place to the other, there's lots of interchange depots that already exist today in the diesel system. So, if we look to the difference you've got with the tractor today, a tractor can do everything.
Did you just say yes? We'll pick up the conversation later on. I think.
I think that's very good. Very good. That's what we're going to figure on. I mean, intellectually, high density region electric grid is an engineering problem. There's nothing kilowatts of great force to use. Long haul is an innovation problem, but we still need to nuts to make that work. So I think it's highly useful. Okay, this is leaks. This is the cargo that needs to go instead. And it's too low. It's too low for the electric truck. So it still needs to, let's see, from leaks to action. Okay. It's not the driving like that. The trailer then goes on to running. Then all goes in under the foot. 3 trucks involved, 1 trailer. Each driver gets one mission and these. So we need to make sure that there is a charge track to each statement. Number 1, we need to have a risk go there. It needs to be coordinated with other firms, and that's where we need a. That's basically how we do it. So it's only effectively, and that's probably this movement.
Okay, thank you very much. I didn't expect to have demonstration. Yes, thank you. I think, unfortunately, that's all we've got time for now. Thank you, but would you like to show your appreciation for all that? Yeah. Right, off you go, guys. Right.
There you go.